Now let's continue with the Power BI modeling part, which I'm going to explain how to create different relationship and what it means actually by creating different relationship and what is the use cases. So before that, let's first explore what kind of data we have now. Okay, as you can see here, this is actually all the tables which you have it. If you look into the right side, we have 2G, 2G table, 3G table, 4G table, and 5G table. This is actually my input table, the original data, which I'm going to use to plot or to have some visualization, which including some KPIs, like for example, traffic, or you can call it sales or whatever the name. And I have imported another two tables, and I called it supported table. One of them is called date tables, which just contains dates, and the other one containing the site list. And let me show you, like here, for example. Here, for example, first of all, the 2G fact, I call it fact table. Usually they call it fact table or the inputs table. As you can see, it includes dates, right? And cell ID, this is means cell level, and you have some traffic data, CS and BS traffic data. And same for the 3G fact table, also dates, speed, cell speed, this is cell level data, and also some traffic data. And same for the 5G and 4G tables. And if you quickly look into any of those examples, for example, in 2G, this is how we have the data. It's dates, site, and the cell ID, then the traffic data. So this is cell level data actually. And just example for the date table, I just imported a table, extra table, like containing the exact dates which is being used in the 2G, 3G, 4G table. For example, these three dates, and like we have this kind of granularity. For example, dates, quarter, year, and so on. And here is the site list table. This is just having the lat and long and the supported technology for each and all of those sites, and this is kind of unique site IDs. So going back here. So in general, the main idea about creating modeling, for example, as you can see here, we have some relations being created and there is some direction with this relation and so on. And the main idea that if I want, for example, now to plot some data between these four tables, 2G, 3G, 4G, and 5G, in the same chart and using dates or whatever, if I don't have a relation created with all of them, it will give you like unclear data. So let me first leave these relations, then we'll go through them again. So now all my relation has been cleared. So now let's see what we can do if you try to plot, for example, sum of data between these three tables or four tables. So now I'm going here. So I will just check the first part. What is the impact on our modeling? So now I'm just creating a line chart here. As you can see in the top right here, I have this line chart and I just give the dates here. And I use this date from the date table. So let me first, before using the date table, I will use just all these tables having a date. So initially I will be using the date table, then I will try it for any other thing here. So now let's plot, for example, if you go to the 2G table, let's plot, for example, this CS traffic thing. So let's plot it here in the x-axis. So first point you can see here, because I'm using different table, it's giving like exactly the same value, which is actually in general summing the 3 days together. So now let me replace this date with the 2G date table. So you see for this x-axis now is being used the date table from the date table support. So I will just remove this one just to show you the impact first before starting. If I drop with this one here and I just make it dates like this. Okay, so this is actually how it looks like. We have 3 days. So actually we have 3 different values for those. But if I use the other one, it will give me the sum of all because there is no relation between this date table and the 2G fact. So you cannot use, like you cannot have interconnection between different data inputs or the like fact tables or support table unless we have a relation. This is the first point I would like to highlight. Now if you try to plot, for example, the same, for example, traffic, just to plot it with the 2G traffic, see now what will happen. The 2G is still giving different values because we are using the dates x-axis from the 2G fact table, while the 3G is giving now again same scenario, which is the sum of all the traffic of the 3 days. And if you plotted 4G also traffic, this is actually will give you exactly the same image. For example, it's called VoLTE traffic. This one, let's put it here. So again, we're expecting to have the same value all over the way for the 2G, for the 3G and 4G table, because all of them like they don't have a connection with the 2G table. So here where the relations come into the figure. So actually what will happen? First of all, in this particular scenario, the first advice we would like to do it like whenever you have relations, try always to have this kind of support tables with unique values. Don't like try to avoid this kind of avoid any ambiguous relationship. For example, avoid creating like between this tables, fact tables, creating relation between of them. If you want to connect all of them, the best solution ever to have a support table. So now let's try to do this. First, let me replace this date, okay, with the date table date. So I will just show you the best, the first use case for this one. So now if you look into this, you'll find that all of them, the 3 days having the same value because it's summing the value for all these KPIs for the 3 days altogether. So now if you want this to take effect and to be very effective and you start getting normal trends, what you need to do, you need to build the relations between the 2G, 3G, 4G, and 5G table and this date table support. This is the first part. So let me go to this model view now and let me tell you what we can do. First, I would like, this is the four in between. This is, I call it fact table or the table inputs. And the two on the right, one on the right side list, I call it support table, and the one on the left, I call it date table. So first of all, one of the first important points or tips you would like to consider whenever you're doing a relationship, try to have like the naming convention to be very clear, adapt a clear and consistent naming convention. So for example, if I'm going to align some of these, for example, here I would like to align the date. So try to have the same name just to make sure. So there is a direct way where you can create a relation. For example, if you drag and drop this one here to the date, see now it's creating a relation. And if you see this direction, the direction is moving from this table to this table. And this is automatically detected from the system. And I will explain this also in the next, here in this session. But you can see this relation. What is the meaning of this relation? First of all, if you click this one and you make, for example, you can see here is the direction. This means this arrow. This means that this table is controlling the 2G fact table. But the other way around is not the correct. If you make the filtering from the 2G, it will not impact the date table. So this will be showing as well. So this is the first part. And if you look into this, so this is the first part how you can create. You just drag and drop for the data which you want to create a relationship. So I create a relation between date and date. Now there is another method. If I collect above here, you can see add, edit, or remove relationship between tables. This is also one way around instead of doing this direct things. So let me first, this is C. This is a relation which has been created. Here you have the 2G fact table, which is the data set. And we have this date table, data table, or it's called date table supposed to be, which is our support table. So if you check this edit thing, you will find that here, the date is being aligned with the date. That's why it's highlighted by gray here. And you find that that relation type is called many to one. This one, you can say many to one. Many means what? Means that you have one of the tables with many inputs, not a unique one. For example, this table is cell level, so this data is being repeated for each and every single cell. You can see, for example, you have 23rd for this cell, then again 23rd, then 23rd. So this is a relation, it's many to one. And this is one because here the data is unique. You have only three inputs, which is 22, 23. That's why it's directly take effect of many to one. And here, this is a single cross filter. Actually, if you're trying to make it both, see, like this can now, if you make it both, this means both tables can control each other. If you make a filter here, it will impact this table. So the best way around here for this scenario, it should be single. You should only make the control from the table support. And as long as it's many to one, as long as you have one, so the direction will be always from the table which has a unique relation. So this is, let's do like this. It's already created. So just I will show also practical example how these kind of things is impacting each other. Now we would like to create the same relations for the other four tables as well. So now I would like to take what you can put anyone here, for example, the 3G fact table. And now I want to connect it with the date table support, right? Again, I would like to align. You can just click here, then shift click, for example, the other one. So now it's date and date, and directly it's taking the effect, make this many to one and single because we have table with unique values, another one with many values. That's why it's many to one and single relationship. And this support table will be controlling this one. And by the way, if you did it opposite way around, for example, from here date to, for example, 3G, and you again did like this, it's still working, but we call it just one to many. But still, the control is coming from the date table, which is above one. But just they change it instead of many to one to many, because the table in the above, this is having unique values, while the second one having many values. So, for example, let's try what we see and what we can get. So this is now the second relationship. Now I would like to create the remaining. Let me create the remaining with an easy way, which is drag and drop. See now, the same direction of this table. This one means the table will control only this one because it's only one direction. Now I'll drag and drop the date here again to the date here. Okay. Also the same idea, the date here to the date here. Okay. Usually I like to organize it like this. This is a better way to keep the fact tables in the middle and just to keep all the support tables around here. So now I created a relation. Now let's look into our data, how it looks like now. See now it's very good taking effect each day having a different day because first of all, the connection is being built between these four fact tables and the date table support. So now that's why it's taking effect very normally. So now each day having a different value. So now you can start building a relation very easy. This is the first point I would like to highlight here. And if you again try, for example, to remove this date table, you can, for example, make it as a slicer now here and just make like date and convert it to filter, for example, a filter slicer here. If you collect it into filter and you select it, for example, only one date, see what will happen. Now it's controlling like I selected today, 23rd, 22, and 23rd. If you collected only one, so now this table, because you build the connection from one direction, from this table to the four, now this table can control all of these tables. And you can now use anything you would like to know. For example, you have another inputs here. All these like are now can be used because you have a relationship between the date and the date. So for example, if you would like to use the day of the month, or for example, let's try, for example, take the day in the week, this one, okay? I'll just put it here. I will just convert it to slicer as well. So yeah, let's day of week name. I just need the week name first. See, this is like killing Monday, Sunday, whatever. So again, if you collect here, so now you can know like this is 2022 and so on. So this is what now we're taking effect. So this is one of the actually this will be almost your case scenario all the time. So now you just remove the filter. Now I would like to show you like the other one. For example, this is the exactly same idea that we have a unique site with unique site ID, and here also those one having the same, which is the site ID. So for example, now if I try to use this site ID, just for example, let's say that you would like to check this particular KPI for only one site. So now I just changed the format of this one, make it as a text because I would like to have it as a filter like this, and I changed this one to a slicer. And now you can, for example, you can now make it even with search or whatever as we discussed in the previous session. So now, for example, if I try to filter on this site 1000, nothing will happen because we don't have a relation between these tables. Now let's try using, for example, this site ID from the 2G table. Now let's try drag and drop here again. And let's try it also make it as a slicer. Okay, and now let's select this one. See what will happen? Now you can see the data changed for only 2G, right? If you clear this one again, now only 2G is changing because this table is only under the 2G and there is no any relation created, so the other two will remain the same. So now let's remove this now. And now if you would like to control it with cell level, so site level, you need now to go and build a relation between again the four fact table and the site table ID. So again, you will go here and I will just do it quickly. You will not like now you need to take the 2G and drop it to the 2G site ID. And also we'll do the same here. And again, it will be only one direction. With direction will be that this table is supporting the other. That's why you can see this arrow is showing this kind of direction from here to there. So now, going back to the data, if you check this one now, if you can click one side, now it will effectively give you values. And this site actually doesn't have data because it's not supporting, I think it's only not supporting this kind of having very low traffic. So for example, even a drag and drop from the technology here, which under the set list, I drag and drop the technology. So I said, select this one. I'm expecting only to have the 3G traffic only because here it's missing 3G only. Means this particular group of sites supporting 3G only. If you click into 4G, now it's making filter correctly. And even now you can even do another filter using site, a particular site. See? Yes. 4G and the 5G collocated. Let's change this one to slicer. Okay. So let's also change this one to slicer just to make sure it will filter. See now, once I change it because it's slicer, it's impacting this side. So now I can check for only one side. whatever. So now your filter is being working because you build a relation between here and there. Now I would like to clear the concept in general, like what it means by this kind of having this kind of what is the differences between many to one, one to one, one to many to many, and what is the difference single and both. So let me give you an example. And actually, the main point here, that always try to understand the relationship type. And this is if you understand it, this is will make it more easy for you, like to build like a strong model and so on. And actually it's not that difficult, as long as you are having this kind of understanding of having support tables all the time. This is will make it easy for you. So now going back to the data, I would like to explain to you what is the differences between all this kind of relationship. So now the current relation which we have it, we are have built, for example, from the site ID. I have built that this table can control all these four tables, because we have, if you click into this relation, it's moving from this direction to this one. This means this one will have control all this table, and we have relation B equal for the other four. So this table can control all these four tables. So now going to this data. So once I, for example, can see the figure on the left, I just give the site count based on the 2G table here. I have the site count, unique site count. I just, if you like this one, I just make count the distinct. And I did the same for the 3G. This is actually called 3G name. Let's change the name just to make it clear. Now this is a 3G site count, this is a 4G site count, and 5G. And this is the total physical site count. If you click here, this is from the database. So now if you click here in this particular area, which is having this filter, I'm using this filter as a slicer from this particular table, which is, as you mentioned, that this one is controlling the other four now, as shown the below relation here, below created relation. So now if you look into this, now if you click, for example, 1000, see what will happen. Now this one gives 1, 1, 1, and here there is no 5G side. That's why it's giving a 0. So now if you collect another one, also it will be exactly the same. And let's now try to put another filter. I will remove this one. I will put another filter, for example, from this particular area. As you can see here, let me copy this slicer. I will just copy it here and put it here. As long as this one is controlling all the four, so you can use any filter from this area. So I can just, for example, take the technology and drag and drop it here. Now, for example, if I click only to just site only, see what will happen. This all blank, you have only 17 sites supporting 2G technology only. And if you click only in 4G collocated sites, so you have in total 1,110 sites with supporting 4G and 5G, and under this one having this kind of technology. So now this is the main idea that we already showed it in the previous example, but now I would like to show you the other examples for different relationship type and how the impact will be done. So for us, allow me first to clear all this relationship, then we can go through one by one again. So now let's try to create different relationship type from the site table to any of those. So for example, let's create from site table to 3G table. So I will drag and drop, supposed to be here, come from this one. We take this one down here. I would like to take the site ID and drop it to site ID. So I will just create it from above here, manage relationship. So new. So I will select, for example, the fact table, which is 3G. Okay. Then I will select this site list table. See, now it's automatic take effect because the name convention is the same. But now I don't want to make it many to one. First of all, keep it many to one, but let's try this both direction. What will happen? Both direction, this I'm expecting to have this arrow from both direction. This means this table can control this one and this. So any filter here will apply here and the opposite way around. Let's see. Just to have a more clear understanding. See, now we have this direction from the table is both direction, right? So if you go back here, now I have two filters giving here. This, let's make it based on the, I'll just change this name. Since I'm giving 3G, so let's keep it 3G. Yeah. And let's change the data here. See, this table is having the ID from site ID, but I built the relation between 3G and the site list table. So I'll remove this one. I will take the site ID from here, from the 3G. Okay. I make it both direction, all right? So this is the data inputs, and this is the support table. So if I make a filter here, what I'm expecting, this table now is controlling the 3G. So this one should having now the physical site count, which is from the site list, should be having 1 if I click only one side, and also 3G will be 1, and the other will be the same. So let's see. See, now it's changing, and even this filter become now only 1. Now if I remove this one and I did the opposite way around from the 3G, just to make the filter, which is the fact table here, this one. If I click here now, See, now it's fine because I make it both directions, so both tables can be filtering each other, and this is not a good idea. Try always to give it a single way, especially when you have one-to-many relation. So this is the first one. Let's now going back here, and let's try to change again this relation type. If you check this edit now, you have another one-to-one. This is actually, it will not be double. It's not applicable because actually what we have here, we have one table doesn't have a unique, and only one table having one can be a relation. So this relation is not applicable one to be one-to-one because this is only applicable if you have one-to-one relationship between both tables. But this table, as you can see, for example, decides as being be repeated each day. So this is not a unique. This is many relation, so it cannot be double. Again, for this one, it can be done, no problem. But this is actually should see. This is one to many. It cannot be done unless you change it the table direction. This one should be above site list because this is one. This one is reflecting the table in the above. So the table above having many, not one, and the table below having the unique direction. Should be many to one. This is also cannot take effect. If you change it many to many, okay, it can be working, but he giving you an advice that this table, this kind of relation is not support. It's not supposed to be created unless you have neither the columns in this site ID and site ID having contains unique values, and this is not our scenario now, right? Because you have one table was unique and the other was many relation, many site IDs and whatever. And now this is like you can change also the cross filter direction both. Also, you can change the site direction, which we want, like which table to control each other. For example, if I make a site list here, this means this one will be controlling this one, and if you make 3G table, it means this one will be supporting that, or if both will be site. But this relation is not recommended to be built. If you do it now, I'll show you a quick example. If you build this relation, this is you should be build it whenever you have many to many relation. Now let's see. Now I selected the single site list. So this means support table filter 3G fact table. So this means this table will be filtering the 3G table. So if I click here now, okay, and make okay. Now we'll change this one first. Now let's see this how it looks like. Now it looks like what? Again, the direction from here to there. This means this table is is controlling this table. So if you go back here and you change it again, this is the fact table. The support table is controlling the 3G table, the fact table. So if you click here now, this one will be 1 and 1, but not the opposite way around. That's it. Actually, we are almost like cleared it all. But just to make it clear as a notes, try always to have the support tables, which is not related to your fact tables or your input tables, and try always to make like these kind of tables to control the support table to control the data within the other tables, just to build the connection between both of them, as I gave the examples in the beginning. This is the one of the notes. Also, try always to have this avoid bidirectional relationship as much as you can, and also try to have a naming convention clear, and always check like for unique values. Like for example, this table, this site list table, ensure you have a unique site IDs here, because actually the main idea that to ensure that the column used in the relationship have a unique value. Otherwise, this is relation might not work as you're expecting, and also it might impact your aggregation. For example, assuming you have two site ID with the same, but with some like discrepancies within your information. If you go back here, for example, site list, assume that this sign is being repeated 1000, but you make it one time for 4G and one time for 3G. So this means that this like will impact the aggregation at the end. So this is also one of the advices you need to consider it whenever you go. And that's it for the modeling part.